All right. Welcome to Chapter 9, review, work, energy, simple machines. When I say energy, kinetic and potential energy, work is energy. Remember the unit labels for energy. Where am I? All my markers. Anybody see the markers? I had them. I had a ton of markers. Lisa, can you get that marker? So for instance, if I have work equals force times distance, this is Newton meters, right? And a Newton is MA, correct? And that's going to be kilogram meters per second squared, right? Correct? That's going to be a Newton times, so this will be kilogram meter per second squared times meter. So what do we got? What are the unit labels for energy then? Unit labels for energy would be kilogram meter squared over second squared, which is a joule. It is a joule. Understood? Yes? It is a joule. Clear? All right. So just remember the unit labels. Kilogram meter squared and second squared are just simply joules. It's all the same. Okay, can I erase that? So it's going to be, the test is going to be on work, energy, and simple machines. And remember, kinetic energy, potential energy, and work, it's all joules. Okay, it's all energy. Clear? Okay. So we have equations. You'll have an equation sheet tomorrow. These are the main equations. I didn't give you the equation for AMA, but I can do that. It's on the equation sheet. We can write that as we develop this review. Work is force times distance. Now I may say something like, who does greater work? Carrying a 3 Newton box up 2 flights of stairs, or carrying 2 of the same box, of the same weight box, up 1 flight of stairs. So you're gonna have to think, okay? You're gonna have to think. Power, work divided by time. Clear? The quicker something's done, the greater the power. So the smaller is T, the larger is P. The faster something is done, the greater the power. Allow the equations to help you understand the concepts. It's huge. Do you understand? Know what's proportional, know what's direct, know what's indirect. Know when one variable changes, what that does to the whole quotient. Clear? An example would be, the smaller time is, the quicker something's done, how does that affect power? Okay, so work is force times distance. Power is work divided by time. This is the equation for machines. This is the weight of the box. This is FW. This is the distance you have to lift it, and this is the machine. So the idea is that this is a larger force with a smaller distance, as opposed to the machine side, the smaller force with the larger distance. They should be equal, and that's ideal. This is what it should be. That's what I'm saying ideal. It's the minimum. This is going to vary based on friction of that. That may be larger than it should be. That's something to consider. Don't forget, potential energy is mgh. Kinetic energy is 1/2 mv squared. The sum of the changes have to equal 0. This is momentum. There's a couple of questions that relate momentum to energy. Okay? Well, you can see it right here. If something has kinetic energy, does it have momentum? Yeah. Doesn't it? Isn't momentum mass times velocity? So if something's moving, this is moving. It has kinetic energy and it also has momentum, correct? So this is going to be FO over FI, correct? Now, this is going to be DI over DO. Now you can see this as FI, if FI has friction in it, that denominator will be higher than it should, correct? Therefore, the AMA will be lower than the IMA. Yes? The AMA and the IMA should be equal, but it never is. The IMA is what it will never change. It's based on distance. That's the ideal mechanical advantage. AMA should be the same if it were 100% efficient, but it never is. So this value will be lower than it should be because of FI. If FI, that's the application force, that's the applied force that you're applying when using the machine. If there's friction involved, then that value is higher, correct? Yes? Okay. So efficiency can be the AMA divided by IMA, right? That would be, and if you want to say percent, I may say percent efficiency, just multiplied by 100, but remember it's multiplied by 100. If you're going to use efficiency in a calculation, you have to make sure that it's the decimal equivalent. Clear? And that's really it. I would recommend highly looking over the videos that I uploaded. I know that I uploaded 10,000 videos, but you should still review them. Especially the last one I uploaded on that, when I did the ramp, I did the inclined plane. After that test, this is what you're going to say to yourself. If I asked you, now do you understand why I asked you to watch that inclined plane review? And you know what you're going to say? Yes. Okay? Because while you're doing those problems on the test, you're going to say, okay? There's going to be several types of questions. There's going to be 50 multiple choice questions. There'll be questions that are purely conceptual. If you don't know the concepts, they'll be impossible. If you do know the concepts, they'll be very quick. Then there are questions that are calculations and conceptual. Then there's questions that are they're just calculations, plug and chug. Understood? So you have to be able to do all kinds. Understood? And are there questions? Questions? As I get older, my neck, I get this arthritis. Oh my God, it hurts. I don't stand up straight, do I? My head. Yeah, it's like, oh, my head. That's it, that's all I can go. Anybody? I know, it's weird, I know. Terrible. That it?